All right, friends and neighbors, in this particular Python video, we are going to go over sort of two ideas. Maybe one is functions and why we do them, and then also comparing something that might be able to be repeated versus what we might call a straight line or a linear program. All right, so we're just going to start off with some basic math, and then we'll just say, well, what if I wanted to do some stuff with this particular math program? So we're going to start off with a variable, and we're just going to say x equals 5. Okay, so now x equals 5, and I can do something like, oh, I don't know, print x is, x, something like that. And we'll save this. There we go. X is 5. Okay, I guess I accidentally ran it twice. All right, now what if I want to do something with this? And we'll do a couple of really basic Python functions, right? We'll say x squared is equal to x times x. I know it's really, really high level math, but here we go. And then I'll say print x squared is... Now, I won't do too many of these because it'll get tedious pretty quick, but there we go. All right. Now, another way to do x squared, of course, is we could do powers of 2. So the way that you would do that in Python is that you could say we'll do x squared 2 is equal to x. Now, that's the multiplication operator, but if we do this, then we get the same, we get an exponent instead. We'll just sort of shortcut this a little bit. There we go. All right, so we get the exact same thing. Okay, so now let's get back to our original x. And we'll say, well, how would we do that? Well, if we want it, what we're after is the square root. Well, what is the square root? So if we use the same idea, the square root is actually the exponent of 0.5. So if we say x square root, maybe like that, oops, square root is equal to, and then we'll say x asterisk asterisk 0.5. Then I'll say print the square root of x is something like, oops, something like this. What did I call it? X square root. Now this took the square root of 5 instead of the square root of 25, so I could maybe, oh, let me show you one other thing that we could do here. We could say, we could do it in one go. So I could do like this. I could say, let's actually add, square root of x is, instead of doing the operation like this, instead of saying I'm going to set this variable and then I'm going to print the variable, I could say the square root of maybe x squared is equal to 0.5. And so what this does is the calculation actually right here inside the print statement. So that's just one way to do it. There's lots of ways to do this, and we'll just see what this does. Okay, so we're back to our 5 here. Notice that it changed to a float because we're doing calculations. And maybe what I could do is this also. I could say something like this, right? Because I'm looking at this right here, and if I want to, I could say, well, I want a line feed in there. So this will give me a line feed like that. So you see the difference in the output here. Okay, so all of this is really, really straightforward. It's not really the point of the video. The point of the video is we have questions when we do this. What if I wanted to run multiple calculations of the same time? So what if I wanted to do the square a bunch of times? Or what if I wanted to do the square root a bunch of times? Or what if I wanted to say, instead of hard coding means that we put the value in the program, instead of hard coding this value, what if I wanted to ask the user how to actually run the program? That is to say, what would the user like to do? All right, so what we're going to do is create several functions here, and then we'll go over an idea that was in one of the very first videos in this series, and we'll put it all together. So maybe what I'll do is I'll say I'm going to create a function with the def statement here, and I'm going to say this function is called user input, okay, like that. And the other thing that I'm going to do is right away we're going to talk about our main program. So when you have a function, you have to at some point call the function, and you have to define the function, of course, before you call it. So I might say something like this. Value in this case is better. Value equals input. Please give me a number. Like that. And I could say print value or return value. Maybe we'll just print it here. Print value. Right. Now, I have to call this function. So normally what we might do is say, I could do just something like this, right? I could say user input like that and call it. And let's just see what happens when we do that. Okay, so you can see the prompt down here. Hopefully y'all can see this in the video. So now it's asking for a number, and we'll give it 3. We'll give it a different number so that we know. And then you can see that it printed 3 because of this statement here. Okay, so that is how the input would work and how we would get the value back. Maybe that's one way to do that. We'll cover another way here in a second. But this doesn't solve the problem of all of these math functions. So let's create a few more functions for this. So we'll have a square root function, and then we'll say that we use y in this case. Y is equal to x. We'll call it choice or value. Right? We'll say value. Now you can reuse the same variable names all over the place. You just have to be careful when you do that. We're doing a simple program, so maybe using the same names will help us follow through what's going on here. But if this is a square root, so we're going to need this kind of thing here. But the problem is, what is value? This function would have no idea what value is. So what we have to do is we've got to pass value into the function. Okay, so how would we do that? Well, I would say something like this. I would say I'm going to call square root now, but instead of just doing this, I'm going to say we're going to pass it value. But we have another problem. How does value get back to here? Well, this function that gained value, the function that figured out what value is, would have to give us value back. And so what I could say is like this. I could say return value. Okay, now if we stop right there, why don't we see what happens? Right, we've got these functions called, we have them defined. Okay, let's see what happens now. We'll save it and we'll run it. So we'll use 4 this time. Oh no, right? Value is not defined. So at some point, we said we're going to return value, but where did this fail? Now, one of the things when you're getting started with programming, one of the easiest things to do is add print statements. So an easy thing to do is to say, well, I got value back, right? So value was printed right there. So maybe in this function, I will say, I'm going to print that I am inside the square root function. And that's all that I'm going to add. And then we'll run this again to see why it dies. And we'll use 6 this time. Okay, it never made it to the function here. And the reason that it never made it to the function is that while we returned value here, we didn't define what value might be in our main program. So one of the things that we might do is we could say value equals whatever comes back from this function. And so we'll save that and run it again. Okay, so we'll use 7 this time. Oh no, what's going on now? Well, when we do this kind of operation, we got to remember that we're trying to deal with a numerical value. So let's do this too. Let's add something like this. We'll say print, print, what is the type of value? And so all that we're asking Python to tell us is, what kind of variable is this? And we use 8 this time. So it's a string. Now what we did is we passed to the square root function an actual string. And so when it got over here, you can see now we progressed to the square root function, and then we tried to do a numerical operation on a string. Now it turns out that you can do some numerical operations on a string. I will show you one right quick here. Print, oh, I do that a lot. Print value plus value. And we'll save that and we'll see what we get. Okay. And we'll do 8. Now we just did 8. Do we do it? Yeah, we'll do 8 again. Okay. So 8 plus 8, if they're strings, is 88. Of course, that's not accurate, but it's just string. You can do some operators on strings. Okay. But the problem is that this particular operation needs a number. So what we could do inside here is we could say either when we call it, we could change what kind of variable value is, or we could just do it inside the function itself. So I could say value equals int a value. So I could just do that. I could just say, I just want you to be cast as an integer. And let's see what happens now. And just for fun, we'll use 9. Okay. So in square root function. All right, so it looks like it worked, but I didn't print out the value. I just asked it to do something. So we could say print y is y. And let's go to 2. We use 2 this time. Okay, so I'm in the square root function, and there's the square root of 2. For all you trig and geometry folks, you recognize that number. Okay, so this looks okay. I feel pretty good about this program, except for maybe one thing. I can't use y after I'm done with this calculation, right? It just happens inside the function. So again, we could say, well, I want you to return y for me, which also means that I would need y over here. All right. Now there is one other operation that we did up here. We were doing the squared function. So we'll make one more. We'll call it the square function. And we're going to pass it a variable. We don't know what the variable is, the name that we want to call it. I don't want to use value right now for a very particular reason. So I am just going to say some number. Now, the function is expecting one variable here. It doesn't actually matter what name you use, as long as you understand that the function is going to reference this value, and if when you call the function you put something else in there, that's okay, but the function itself is going to use this. So what I'm going to say is num squared equals num, right? And then we'll use our asterisk like that. And then we'll say return num square like that. And then down here we might say, now watch the call here. So now I have y back. So now I'm going to say I'm going to send y into the square function. So I'm going to say square function, and I'm going to pass it y. Okay, but I'm returning something. So now I'm going to say out here, num square equals the square function of y. So we're gonna get y back from here, and then we're gonna send it right over here. Let's see what happens. I don't know. I'm a little nervous now. We're getting to a really big program. I don't know. Oops. Okay, so let's run our program, and we'll do 3 maybe. Well, that looks pretty good, but I forgot to print out here. So now that this is returned, I could say, well, print. We'll just do it quick. Num square, right? 4, and there it is. So y is 2, and then we get num squared is 4. Now this is all well and good, and this program pretty much does what we want it to, except for one thing. These function calls can get lost in all of these crazy statements that we use. Okay, so since we're going to modify this program yet again, I'm going to get rid of some of the early stuff just to make a little bit of room on the screen here. Okay. And we'll do something like that. Now, all of this stuff right here is fine, except that it's not wrapped up in a sort of a one-stop shopping place. Now, what we can do then instead is we can do a main function. So I'm going to say def main now, like this. And then because these things all become part of my main function, I'm going to indent them. By the way that I've structured this is in accordance with something called the PEP8 format or structure guidelines. If you're looking to see why we build programs the way that we do, this is sort of the standard for Python. Now, one of the other things, since we're talking about what you want to do in a program, what you might say is something like this. You might add some comments at the beginning that say, this program does math stuff. So everybody knows. And you might say in each function, something like this, this function brings in a user value, right? And you could do that with every function like that. I'm not going to take the time to do that now. So now what do we have? We have what looks to be a much cleaner program, right? We've got these functions, and in our main, we're going to call each function, and we're going to bring a value back from each function. Now, how do we call them? Well, the way that you would do this is just like this. You would say, I'm going to call main. So now I have really one function call that's outside of all of my other structure, and then when main gets called, all of these other things happen. Now, there is one other structure that you might see. You might see this. And if you remember from a previous video, this is called a double underscore or a dunder function. And so this is dunder main. And so your call for this might look something like this instead. It might be if, dunder name is equal to this, right? You might see a call like that. Now this is sort of a next level call. It turns out that dunder name has a very particular meaning, and it usually references dunder main. And so it is a way to specifically call this, but this has particular meaning. And I would encourage you to take a look at that. So I did a video on it in the first one, but because we're doing just a fairly straightforward program, we're going to stick with our original main call like this. Okay, so let's see if our operation is any different. Okay, so we're going to give a number, and we'll use lucky number 7. Well, let's see what lucky number 7 was doing. We were calling the user input. That's why we got 7, right? And then I said print 7. So that's why it printed right here. And we brought value back. And so value came back right here. And then we asked it to print the type of value. It turns out it's a string. And then we said value plus value, right? And that gave me 77. Of course, it's not a number 77. It's just two strings put together. And then we called square root, and we passed it value, and then we did some stuff inside here, like that we're in the square root function, and we calculated square root. We printed what it was, and then we returned it. So we set it equal to the function here to get it back to the main program. And then we passed y in here, so we got the square root of y, or we got y being the square root, and then we passed it back in to the squared function, and then we print num squared. Now, what's really interesting here too is this is just a side benefit of this this particular video. We started off with 7, and then we got this number back. This sort of gives us an indication of the memory limitations of Python. So when we did the square root, right, this is a rounding square root. It's not the absolute square root out to as many decimal points as you need it. Python has limits by default. Now you can manipulate this. You can truncate this if you want. But then because this is rounded and we had Python limits in memory, here is the square that we get back. So close, but not exactly the same thing. Now, if I did something like this, print int of num squared, let's see what that does. And we'll do 7 again, because we just did it, right? There we go. Okay, so we're converting that to an integer, and Python does the best that it can, and that's how we might manipulate that. Okay. So what do we got here, right? We have a bunch of different functions. Now, one of the other benefits of the function is that if we had done all these in a linear program, we had no ability to call the programs or redo the lines of code. If we wanted to do the square root function a bunch of times, how would we do that? We would have to have written that code again. But now, because we have this square root function, we can just call the square root function again. So, and I can pass it any value that I want. So now I might say something like this. I'll just call square root again, and I'll say z is equal to the square root. Well, what would we do? Well, we have a num squared here, and num squared, we did bring num squared back to the main program, so we can send it right to another function and see what happens. And then maybe we'll print it off again here. Actually, maybe we'll print it in the squared function, so we don't have to do that again. And that way we don't have to rewrite that code either. So we will print num squared, and then we'll say num squared, like that. And as long as I spelled everything right, we should be okay. By the way, this part of the print statement is just putting this in quotes, so that becomes text on the screen. And then this, I have a comma right here, and then I say, here's a variable that I want to print. Okay, so we'll save that, and we'll run it again. And this time we'll do 8. So if we're following this through, right, please give me a number. We gave you 8. It's a type string. There's our 88 again. So here is the square root of 8. And then we squared 8. We took the integer, or we cast the return, which was a float, as an integer. And then we went back to the square root function, and we did the square root of 8 again, which means that we should get pretty close to this. So, you know, we did the square root of 8, then we squared it again, and then we did the square root again. So we got, you know, we start with 8, we go 2.8, then we go back to 8, and then we go 2.8 again. Now, I could have done anything here with a new value. I could have said also, we'll do this one more and then we'll call it a day. I could also have said new value is equal to user input again. So I could have asked the user input or user for input again. And maybe we'll do that. And let's also clean up some of these print statements, right? We don't need all of these now. We were doing this just for an example, and we were doing this just for an example. This was just an example. So I could delete them, but we'll be really clear about what we're doing here. So now I'm adding a new call here. Now instead of sending this value here, let's send new value into our program. And we'll run it. So the first number that we'll give is, we'll do something different here, maybe 10. Okay. So there's the square root of 10. And there we have another call. And now we'll do 11. So in the square root function, so here's the square root of 10, 3.16. Here's the square root of 11, 3.31. So there we go. Okay, so just to quickly recap, this is a program that's based on functions. Functions give us a lot of freedom. We can call them again. It's an organizational structure, right? This looks much cleaner than the linear or straight line program that we created before. I can easily reuse code in this particular case. We also see how to pass values into a function and then also return them from the function. And lastly, we've got our main program here. And the main program, this is a convention. You can do it a lot of different ways. We either use a main function or a dunder main, and the main function's job is usually to set all kinds of variables that you might use that are global. And you also use main to call all of your other functions or to set values back to what they were to be originally. So that is our basic structure for today. So I hope this helps you understand a little bit about why we structure programs the way that we do and maybe how to pass values into and out of functions. And with that, we'll just say, hey, this is Python and programming. You can do this.